Hi, it's Sulphur, and today I'm going to be explaining some information about the periodic table. Scientists in the 1860s knew some of the chemical and physical properties of more than 60 elements. However, there was no general system of organizing the elements. Dmitri Mendeleev is a Russian chemist. He was one of the first scientists to design a way of organizing the elements. In Mendeleev's periodic table, Mendeleev arranged elements in rows by increasing atomic mass. He started a new row each time the chemical properties of the elements repeated. So, for any column, all of the elements in that column had similar properties. When Mendeleev arranged the elements in a list, he left gaps in the list. As you can see here, he put question marks in some gaps. The question marks indicate places where there was no known element whose properties fit the pattern. He predicted that new elements would be discovered that would fill those gaps in the future. He used each new element's position in the periodic table to predict some of the properties of the elements. For example, Mendeleev left space for element after silicon. He predicted that this element would be a gray metal that has a high melting point, and then the element germanium was discovered later on. A few elements in this periodic table didn't fit the pattern. He found that some elements didn't quite fit the pattern. For example, he had to reverse the position of the elements tellurium and iodine. When he did so, they were in columns with similar elements. However, they were no longer in order of increasing atomic mass. Mendeleev thought that perhaps the values of the masses weren't accurate, but later experiments proved that the values were correct.
Eventually,
About 40 years after Mendeleev published his table, the English chemist Henry Moseley arranged the elements by atomic number rather than atomic mass. Today's periodic table includes 118 elements. Now we have the modern periodic table of the elements. There are 18 groups or columns and 7 periods or rows. The two rows at the bottom, they're just lanthanide and actinide. They are there to not make the periodic table bigger. That's the only reason. And you can see that the first group has 1 valence electrons, the second one has 2. From 3 to 12 it varies. And from 13 to 18 you get the group number, subtract by 10, you get the number of valence electrons. For example, group number 13 minus 10, it will be 3, so 3 valence electrons. Number 14 minus 10, you'll get 4. So group number 15, the minus 10, you get 5. So the number of valence electrons is 5. Till group number 18. And as you can see at the symbols below, the group number 1, which is purple, they are alkali metals, except hydrogen, but because of the atomic number, they put hydrogen in group number 1. Group number 2, the purple one, is alkaline earth metals. Group number 3 to 12, they are transition metals. And also the lanthanide and actinide, they are also transition metals, but they are more specifically inner transition metals. Group number 13, they are according to the first element in the group, which is boron, so it's called boron group. 14, carbon. 15, nitrogen. 16, oxygen. But group number 17, it's halogens, as you can see the symbol below. And group number 18, they are noble gases. The periodic table, the metals are on your left. The metalloids are in the middle, and the non-metals are the right. As you can see, the green color, they are the metalloids. There are 6. And the ones to the right, they are non-metals. The ones to the left, they are metals. The metalloids are 6. Boron, silicon, germanium, arsenic, antimony, and tellurium. Now let's zoom in, for example, to sulfur. So the symbol S is for sulfur. 16 is the atomic number, or the number of protons and a number of electrons. And then you have the atomic molar mass, or the atomic mass, which is 32.07. And And then, for example, here you have 32.07 and differs between different elements. And then you have the power, which is it happens sometimes when it's ion only. It's 2 negative, which means that it gained 2 because it's easier to gain because it's in group number 16, so it just needs so it has 6 valence electrons, so it just needs 2 to fill its outer energy level, which is 8. So it needs 2. When it gains, it becomes negative. It gained 2, and so it's 2 negative. Finally, I want to say that the periodic table is made to compare and contrast between elements easier and to know what elements they are closer to what elements in their properties. And I would like to thank my dear teacher, Mr. Mohamed Ibrahim, for supporting me and giving me the information.